Yeah, so for introductions, automatic event extraction is a critical tool for analyzing large volumes of textual data across various domains. It enables more efficient decision making by identifying key domain specific information. Uh, However, creating event extraction systems for under-resourced languages like Lithuanian is challenging due to the lack of annotated datasets. And this study investigates the event extraction capabilities of OpenAI's GPT and Google Gemini's using few-shot prompting technologies to address these challenges. And the primary objectives of this study are to assess the performance of GPT and Gemini models in extracting events from Lithuanian text, and to analyze the effectiveness of few-shot prompting methodologies. And also, I would like to introduce novel approaches, such as the combined approach and the layered prompting approach, and to evaluate the performance using metrics such as accuracy, precision, recall, and F1 score. Event extraction identifies and classifies events from textual data, including triggers, participants, and context. For simplicity, the sentence can be identified as event or non-event. And large language models like OpenAI GPT and Gemini, or Google Gemini, leverage extensive training data and perform well in zero-shot or few-shot scenarios. And Lithuanian present unique challenges for natural language processing, such as rich morphology and limited linguistic resources, making event extraction complex tasks. And for this study, two event types were chosen. It's a contact meet event where two participants physically meet. It's involving appointments, conferences, encounters, and contact written phone. It's non-face-to-face communication, including phone calls, emails, and text messages. And when prompting large language model to assess the sentence if it's an event or not event, every prompt should include text description, definitions for event, and their types, few good and bad examples, and the target sentences. And when we get prompt results, we use two kinds of approaches for further processing. It's a combined approach and layered prompting approach. And when using combined approach, two conditions were used, or and. And with or condition, an event is identified if any of models detected. And with and condition, an event is identified only if both models agree the same decision. And when using layered prompting approach, it employed three steps. The first layer is initial prompting, and the second level is stress prompting, asking to confirm the decision, and at the third level, asking to confirm the decision for the second time. For experiment, I chose four models, two from Google and two from OpenAI. And to perform all the tasks, it was developed specific application for this task, which allowed to perform all the tasks automatically using APIs. And of course, in order to evaluate model performance, primary Lithuanian goal corpus was constructed using 200 articles from Lithuanian news websites, and it was manually annotated such mentions before two event types. And using all this setup, and methodologies experiment was performed. And of course, here you can see the screenshot of, from the specifically crafted application for these tasks. And we got some results. And here you can see that accuracy was always good, but precision, especially with Google Gemini Flash, was low. That indicate that models used to over-identify sentences as events. I mean false positives. And if we can use F1 score as the main score by which to decide the best performance, the best performances was harnessing both models with combined approach or condition, achieving quite satisfactory 61.4 score. Also, we can notice that layered prompting approach improved performance for most models, not for every model, but for the most. And combined approach effectively leverage strengths of multiple models, as I mentioned before. And for discussion, I can be happy with quite satisfactory results. And the main thing that using methodologies possing to get even better results, especially by harnessing both models. What about limitations? It's clear that just two events type were used. And furthermore, dataset was quite small too. So, so I can conclude that large language models show potential for event extraction in Lithuanian, and it could be usable for other small under-resourced languages too. Combined and layered approaches can improve model performance in many cases. And also there are opportunities for further improvements, expanding data sets and refining methodologies. And for future works, yeah, we have to do that. Expand annotated data sets, include more event types, and try experiment with more prompting techniques. Thank you. And maybe do you have any questions?